Hello everyone, I'm teacher Guohar Huang. Today I'm going to introduce to you the Unit 11, which is about one-way analysis of covariance, ANCOVA. The sample example we are analyzing this time consists of 45 participants in the raising game group and 32 participants in the no game group. Our experimental procedure involves dividing participants into two groups, the raising game group and the no game group. The first group will undergo a pre-test and system introduction initially, followed by 7 weeks of 1-hour practice sessions each week, leading up to a post-test in the 9th week. Since there are both pre-test and post-test measurements, we need to control for pre-test differences to compare whether there are significant differences in post-test scores between these two groups. First, we click on Analysis, select General Linear Model instead of comparing means, and then click on Univariate. First, we need to set the covariate, which is the pre-test. We need to control for the pre-test because it may influence the post-test. Next, our dependent variable is the post-test, so that's what we want to compare. We have two groups in our study. First, click on Model. Our initial model should include both individual effects and the interaction effect. To select both at once, hold down the Control key. Our primary aim is to understand if there is an interaction effect. For the first model, let's choose Custom first. Then select Group, Pretest and Group, Pretest, and then click Continue. First, we need to observe if there is an interaction between the group and the pretest. If the significance of the interaction term, group pretest, is greater than 0.5, it means it does not reach the significance level. This indicates that the slopes of the regression lines for the two groups are the same and the lines are parallel, implying no interaction effect. In this case, we satisfy the assumption of homogeneity of regression coefficients within covariate groups, allowing us to proceed with ANCOVA. However, if the interaction term is significant, this assumption is violated, and further ANCOVA analysis may not be meaningful. Next, do the same process again. Click on Analysis, then select General Linear Model and choose Univariate. It's the same as before. The post-test is the dependent variable, the group is the fixed factor, and the pretest is the covariate. But the model needs to be changed. Change it to a full factorial design, then click Continue. Click on Options. We want to compare the main effects using LSD. Under the Display option, make sure to check Descriptive Statistics, Effect Size Estimate, Parameter Estimate, and Homogeneity Test. Then click Continue. Then click Confirm to proceed. We checked for homogeneity of variance earlier. Now, let's examine if the variance meets homogeneity criteria. If the value is greater than 0.05, indicating no significant difference, it means the data satisfies the homogeneity test, and we can proceed. If the variance does not meet the criteria, ANCOVA cannot proceed. At this point, we only need to focus on the group. What we're interested in is whether the group affects the semester outcome. Its significance is 0.044, which is less than 0.05, indicating significance. The F value at this point is what we need to record. Then we can see who is bigger than who. Group 2 is larger than Group 1. This is the post-test score, but it hasn't been adjusted yet. The estimate is the adjusted post-test score. After excluding the pre-test, the difference will become more significant. So, we can say that Group 2 is superior to Group 1. The conclusion is the adjusted mean. When displaying this table, in addition to the number of participants, mean, and standard deviation, we also include the adjusted mean. Additionally, there is an F value. The F value is copied from earlier. Since the significance is less than 0.05, we will put 1 star. The adjusted post-test score for the no game group is greater than that of the raising game group. This means that the performance of participants without gaming is better. Game-based learning may not be superior for all students, so many things need to be confirmed through numerical analysis rather than imagination.